Proposition 2 in book 1. To place at a given point a straight line equal to a given straight line. We have to draw a straight line which is of the same length as a given straight line from a point. Fairly simple. We will use proposition 1 again. So we have a straight line. Let's take a small straight line. And we've labeled this as BC. Now the point can be anywhere. Let's put the point here. Just make it a little light. The point A is here. Now in this proposition, we essentially have to draw a line, say AE or AD, which is the same length as BC. In one way, it's fairly simple. We can just take a straight edge, mark it, and then mark again. But that's not how we're going to do it. We're going to do it very elegantly, just using proposition 1. Proposition 1 was about constructing an equilateral triangle. So what we do, we first construct an equilateral triangle on AB. So we'll use proposition 1 and we will reduce the number of lines and arcs to make it very simple looking. Just adjusting my compass. So for an equilateral triangle on AB, first we'll measure length AB on a compass. That's simple. So now we essentially make an arc here and then we make an arc here. In proposition 1, you could say we could have two circles, right? So I've just made this point C with two arcs. And then these two arcs will join by two lines. So here's the point. Let's call it point D. So we have the equilateral triangle ADB. Now what we do next is we just extend the line AD. Suppose we extend it and we extend DB also. So you can see AD has been extended to say E and DB has been extended to say G. This is just a ray essentially. What it's not mentioned in Euclid, but it's essentially a ray which is going. Now what we do is we take this length BC and we take B as the center and mark this. So it's simple. Again, we put on a compass BC as the length. Here we have, and we draw a circle. So we see this circle BC with the radius BC. So this is the same as this. Suppose this point is G. BG is equal to BC. Let's just mark it. So BG is equal to BC. We also know that AB is equal to BD is equal to AD. Okay. Now what we do is we take the center as D and the radius as DG and we draw another circle. We can just draw an arc actually, but let's see. So this will be a larger circle. So you see DG. Oops. So we can see the circle which we drew with the radius DG goes and intersects at this point. Let's call it L. Now this line A to L is important. What has happened is here we have DG. So DG is equal to DL because of this circle, and we know that BG is equal to BC because of this circle, and we know that AD is equal to DB because it's an equilateral triangle. So we subtract AD and BD from DL and DG. So this step we do DG minus AB, pardon me, DG minus DB is equal to DL minus AD. We are left with AL, which is the red one, and we are left with BG. We look at this, BG equals BC, so AL equals BC. So the red lines, AL equals BC. It's fairly simple. AL equals BC.